Many students have problem to understand the household electric circuit, exactly how it is designed. And this is the whole electric circuit, but seems to be a little confusing. I want to make you very clear after one after another in stepwise. Okay. In household circuit, two electric lines are supplied by the electric corporation to each of the house. And these lines first they enters into meter box, but one of the line is called live line, it is symbolized by capital L, and another line is called neutral line, it is symbolized by capital N. Live line and neutral line first enters into a meter box. A meter box is normally made up of wood, or it may be made up of plastic. And inside the meter box, there are two basic components. One is electric meter. Its case is metallic, and after the main electric meter, live line and neutral line both passes through it and comes out. And live line is connected to a fuse, and this fuse is called consumer's fuse. Normally, consumer's fuse is given to the consumer by electric corporation. It is of normally 15 ampere, but maybe somewhere 32 ampere also. And after this, both the live line and neutral line enters into main switch. And actually main switch is double pole switch, and double pole switch means all other switches are single pole switches. They are actually connected to live line only, and they connect or disconnect live line only, but main switch connect and disconnect both the live line and neutral line. If we need to extend the electrical line in a household circuit, then we normally put the main switch off and we extend the electric circuit in our household circuit. Or maybe some repairing, at that time also we switch off the main switch. If we have to go out from a house for many days or few months also, then we'll put the main switch off. It disconnect both the live line and neutral line. And after this main switch, live line and neutral line both comes out, then it goes to distribution board. Actually, distribution board consists of many MCB switches. Here also what I am showing, this is 15 ampere this consumer's fuse, but this fuse, instead of this fuse nowadays MCB switch is used. And in distribution board also, instead of many fuses nowadays this MCB switches are used. Okay, after the distribution board, these two line goes to lighting circuit and power circuit. And before that, I want to show you a video clip which makes you more clear visually about the meter box, main switch, and distribution board. Look at this. A wire is supplied by electric corporation, and this black wire consists of two lines. One is live line, another is neutral line. And there is a lot of wire for convenience, and it goes into the meter box. Meter box is normally made up of wood or plastic, and it has a fuse also. Instead of fuse nowadays, MCB switches are used, and it is sealed. And one, we have to be remember one matter: it is sealed. We cannot break that seal. This is the electric meter inside the box, and there's MCB switch, and it is sealed. If seal is broken, then that becomes illegal. Okay, now wire comes out from this electric meter box, and it goes to now another box, that is main switch. And main switch consists of both the live line and neutral line. Connect and disconnect this connect and disconnect both the live line and neutral line. And after this, the live line and neutral line goes to distribution board. And distribution board nowadays, it is full of different MCB switches, and instead of fused, MCB switches are used. And this, from this distribution board, electricity is supplied to each of the rooms of our houses. Again, look at this. There's the live line and neutral line coming into the meter box, and then electric meter, and then it comes to MCB switch, that is somewhere we have written the fuse also. Same then goes to now uh, main switch and then goes to distribution. Let's come back. We were talking about the distribution board. After distribution board, the live line and neutral line then goes to lighting circuit. Lighting circuit actually consists of bulbs, tube lights and low power appliances, and since it has low power appliances, that's why these devices requires less amount of current, so less capacity of fuse is used in live line to hold them, and normally 3 ampere or 5 ampere fuses are used in this lighting circuit, and this is lighting circuit. Now there is another type of circuit also in a household circuit, that is power circuit. The power circuit consists of high power appliances, the electric iron, immersion heater, etc., and they are supplied with live line and neutral line both. Look at the 3-pin sockets here. 3-pin socket are shown, and one of them is connected to live line, another is connected to neutral line, and live line and neutral line, if both are connected, then it is sufficient to run any appliance. But here another point is also given, and this point is called earthing point. I mean say this power circuit consists of third line also, not only live line and neutral line. It consists of what? Earthing line also. Earthing line, which is exactly not necessary to run an appliance, but this is a safety arrangement. And actually there are many household appliances which have metallic case, just like refrigerator, just like electric iron and electric heater, etc., etc. They have metallic case, and by mistake or by any reason, if the live line is touching the metallic case, and when we touch that metallic case we may get electric shock, and for this the safety arrangement is made, that is the earthing line. Earthing line is actually connected to the metallic case of those appliances in which we have to work at the time of flow of current, just like electric iron. When current is flowing in the electric iron, we'll press the cloth. In the same way, current is flowing in this refrigerator, will open its door, close its door. In the same way, there are many high power appliances also, and the appliances which have metallic case, if there is leakage of current in the metallic case, then we'll get electric shock. But in case of lighting circuit, bulbs and tube lights are used. Once we switch on the circuit, we don't have to touch the tube light, or we don't have to touch the bulb. That's why the earthing line is not necessary in lighting circuit. We do not get electric shock from that lighting circuit. Now, how earthing line prevents us from this electric shock? There is very genuine reason. Now, if there is leakage of current in the metallic case of the certain appliances connected in power circuit, then while touching it, the electric current may flow through our body to the earth, and we'll get electric shock. To prevent the electric shock, what is done? Another line is connected, that is called earthing line, which is actually connected to the metallic case. If there is leakage of current, then the current flows through this earthing line, I mean to say the copper wire, to the earth, because the end of this earthing line is buried into the ground, and it is connected to certain metal plate inside the ground. That's why when we touch that metallic case, if there is leakage of current, there is probability of getting electric shock, but electricity flows through a very easy path only. Instead of flowing through our body to the earth, it will flow through the copper wire of earthing line towards the earth. This way it prevents the electric shock. Okay, this power circuit and lighting circuit, what I am showing here, actually these two circuit is of one room. I mean to say, in distribution board there are many MCB switches. One of the MCB switch is related to the lighting circuit of one room. Another MCB switch is related to lighting circuit of another room of the same floor. And in the same way, power circuit also, one of the MCB switch is related to one of the power circuit of one room, and another another MCB switch is related to power circuit of another room. This way, this is just the that's the model or example of electric circuit only. There are many wires which are connected to this MCB board, distribution board, and we cannot represent all these. That's why this is the example. That's why I'm giving you just the model electric circuit only, which makes you very clear about the household circuit. Okay, I think this explanation and this electric circuit and this video makes you clear about the household electric circuit. If you are benefited by all this, please subscribe my channel and share it to your friends also, and like it. Okay, this much for today.